This video is on the use of the Pythagorean theorem. The Pythagorean theorem states that any right triangle can have its sides labeled A, B, and C, where A and B are the legs or the sides that border upon the right angle, and C is the hypotenuse, the side that is opposite the right angle, which also happens to be the longest side in any right triangle. If you label these lengths A, B, and C, you'll always get this equation where A squared plus B squared equals C squared. We can use this equation to find missing side lengths in right triangles. For example, in this right triangle, I have 2 and 5 on my legs. They're bordering on the right angle, and I do not know what the hypotenuse is or what C is going to equal. So I start with the Pythagorean theorem. A squared plus B squared equals C squared, and I substitute in 2 and 5 for A. So that becomes 2 squared plus 5 squared equals C squared. Well, I know what 2 squared and 5 squared are, so I'll continue that. 4 plus 25 equals C squared. Now I simply add my 4 and my 25 and I get 29 equals C squared. Now to take the C squared to a C, I take the square root of both sides. That gives me the square root of 29, and that equals C. At this step I'm going to need a calculator. It is useful for me to know that 29 is between 25 and 36, 25 and 36. So I'm going to expect that the square root is somewhere between 5 and 6, probably somewhere close to the middle. Now I need my calculator. And I hit 29. I take the square root. The square root of 29, my calculator says, is 5.385165. But I know that square roots like this are irrational and it really continues on forever. What this is a rounded square root. It's rounded to probably more decimal places than I need. I can just look at this 5.38 and round that to 5.4. Depending on the instruction of my problem. Here I have rounded to the nearest tenth. If I went to 5.39, that would be rounding to the nearest hundredth. Here's another right triangle. But you notice here that the side missing is not the hypotenuse. I'll call it B. I could have called it A. So let's see what we got here. A squared plus B squared equals C squared. Now, if I'm calling this one B, the 3 is going to be my A, and my 6 has to be my C, as we see that 6 is associated with the hypotenuse, and the hypotenuse must always be C. So I substitute in what I have, and 3 is A, so I say 3 squared plus B squared, because B is the side length that I don't know, equals 6 squared. And now the procedure is very similar to the previous problem. 3 squared is 9. I don't know what B squared is, so I simply leave it as B squared and that equals 36. Now to get b squared by itself, I would actually want to subtract 9 for both sides, and that would leave me with b squared is equal to 36 minus 9 is 27. So then b, to go from b squared to b, I took the square root, so I have to take the square root of both sides, is the square root of 27. And again, at this point, I need my calculator to check, but I know that 27 is slightly more than 25, so I would expect b to be a little bit more than 5. Clear, and now I say 27 square root, and if I wanted to round that to the nearest tenth, I would say that b is equal to 5.2.